And welcome to Chapter 5, Section 2. Today we are continuing on with what we learned in Section 1. So really we're just doing the same thing, just adding an extra step to it. So the problems you're going to see now, instead of just giving you a z-score, they'll give you like a word problem. But within the word problem, they're going to give you the mean, the standard deviation, a number that they're asking you about, and we're going to use those numbers to then find the z-score so that we can use the table to find our percentages. So as we go through these problems, the first thing you want to do is draw out the normal curve, and then you want to label your mean, standard deviation, and x. So when I say x, I mean the number that they're asking about in the question. Once you've done that, then our next step is to find the z-score. The z-score formula is take the number that they're asking about minus the mean, divide by the standard deviation, and then that'll be the z-score that you want to use to look up in the table. And remember, in the table, we only look at 2 decimal places at a time, so whenever you find the z-score, you just want to round to 2 decimal places. And then our last step is to use the table like we've been doing in the last section to find the percent. So let's try it out with our first example. So it says a survey indicates that people use their cell phones an average of 1.5 years before buying a new one. The standard deviation is 0.25 years. A cell phone user is selected at random. Find the probability that the user will use their current phone for less than 1 year before buying a new one. So that right there is like our question, even though there's no question mark. But that's what we're trying to find. Find the probability that the user will use their current phone for less than 1 year before buying a new one. Assume that the variable x is normally distributed. So remember, normally distributed means we should be drawing a normal curve. Is the probability unusual? So let's find the probability. So step 1, we're going to draw this out. So draw the normal curve, label the mean, the standard deviation, and x, whatever number they're asking about. And then we also need to shade in the direction that we're supposed to. So reading through the problem, I've identified that the mean is going to be 1.5. The standard deviation is 0.25. So the mean goes right in the middle. The standard deviation goes on the side right there. And then the number that they're asking about for us, the x, is going to be 1 year because that's the number that's being asked about in the question. So 1 should be to the left of 1.5 since it's smaller. And then it also says less than 1 year. So less than means smaller than 1. So we should be shading to the left here. So the direction you're shading is always based on the words that's in the question. Okay, so this is our picture. Step 2, find the z-score. So plugging into the z-score formula, we have z equals our x value of 1 minus the mean of 1.5 divided by the standard deviation of 0.25. From that, we get negative 2. Whole number, there's no decimals, so I'm not worried about the 2 decimal places. All right. So negative 2 is my z-score. If we are using the table and using like the 2 decimal places, it's technically negative 2.00 if you really need to know. But we're going to use our table now to find the percent. That's our step 3. Remember, we are looking for an area to the left here. So from last section, we said areas to the left. This is like the most basic one. Whatever's in the table, that's our answer. So let me scroll down to my table here. So remember, when we're using our table, there's the negative side, there's the positive side. Our z-score was negative 2.00. So I'm going to go down to the first decimal place of negative 2.0 with a second decimal place of 0. The little crisscross will be this 0.0228 right here. Okay, so that means my area to the left is the 0.0228. So as a percentage, and again, I don't care whether your final answer is in a percent or a decimal, either's fine. But if you like percentages better, this is a 2.28% probability. All right, so that's the probability that the user will use their current phone for less than 1 year before buying a new one. Then it asks, is the probability unusual? This is something we talked about before, a while back. Any unusual probabilities are probabilities that are less than 5%. So our probability of 2.28% is smaller than 5. So yes, this is unusual. Okay, so that's our process for solving our probabilities in a word problem. Let's do this again. This time we've got a trip to the supermarket. A shopper spends an average of 45 minutes with a standard deviation of 12 minutes in the store. The length of time spent in the store is normally distributed, so draw that normal curve, and is represented by the variable x. A shopper enters the store. Find the probability that the shopper will be in the store for between 24 and 54 minutes. So now we are given the mean of 45, standard deviation of 12, and then in the question where it asks us to find the probability, it says find the probability that the shopper will be in the store for between 24 and 54 minutes. That means when I draw this out, then this is an in-between probability that we did last section. So first step is always to draw mean of 45, standard deviation of 12. 24 is going to be somewhere on the left. And again, it doesn't really matter like how far it is away from the mean, as long as you can kind of like, as long as it's on the right side, that's really all that matters. So 24 is a number smaller than 45, so it's got to be on the left. And then our other number, 54, is going to be on the right side of 45 because it's bigger than 45. Okay, so we are looking for the area in between, so I'm going to shade right in the middle. And remember, to find the areas in between, you need two z-scores, and then you take the area of the bigger z-score minus the area of the smaller z-score. So here we've got to find two z-scores then. So I'm going to do this twice. I'm going to start with the bigger number, 54 minus a mean of 45 divided by 12. And then I'm also going to do this for my other number of 24. Okay, so my bigger z-score is going to be the positive 0.75. My smaller z-score is going to be the negative 1.75. Okay, then looking in my table for both of these, we're looking for the areas to the left, and then we end up subtracting both of them together. So for the 0.75, I'm going to be on the positive side because it's a positive 0.75. My first decimal place is the 0.7. Second decimal place of 5, so crisscrossing, I end up with 0.7734, and then my other z-score was a negative 1.75. So on the negative side, we have a negative 1.7, second decimal place of 5, so my crisscrossing will be the 0.0401. Okay, so now I get to take those two areas and subtract them together to end up with 0.7333. So the probability that the shopper will be in the store for between 24 and 54 minutes is going to be 0.7333, or if you want to think about it as a percent, 73.33% chance that that'll happen. Okay. Then next part of this question, find the probability that the shopper will be in the store more than 39 minutes. And then same mean and standard deviation as before. So these symbols right here, I feel like you've seen them before. We've kind of talked about them, but maybe you've forgotten. But this is mu. It looks like an M, looks like a U, so it's read as mu. Just means the mean. So this is a mean of 45. This is sigma, the O with a little hat on it. Sigma stands for the standard deviation of 12. So this time for this problem, we're going to draw it out again. So mean of 45, standard deviation of 12. And now that they're asking us about the probability that the shopper will be in the store more than 39 minutes. So first, 39 is my x value then. 39 is a number smaller than 45, so I've got to put that on the left. And then they're asking us about more than. So more than 39 is going to be shaded to the right. Okay, so step 2 is find our z-score. So I'm going to use 39 as my x value minus the mean of 45 divided by 12. And when I do that, I get negative 0.5. Okay, so when I do the z-score of negative 0.5 in the table, remember when you look for the number in the table, it always gives you the area to the left. But here we're looking for the area to the right, so we're going to have to do that one extra step at the end. So let me find that area to the left first. So on the negative side, negative 0.5, and that's the only decimal place, so it'll be the 0.3085 because the second decimal place is technically a 0. So 0.3085, but we don't want the area to the left, so to find the area to the right, then we have to subtract our number from 1. So 1 minus 0.3085, or if you want to think about it in terms of percentages, you're doing 100% minus the 30.85%. When we do that, we get 0.6915, or 69.15%. Cool, there's our probability. All right, last thing I want to talk about here is slightly different of a question. So here, the last thing I want to answer is, if 200 shoppers enter the store, how many shoppers would you expect to be in the store more than 39 minutes? So here, they're asking about the more than 39 minutes, like in the last question that we did. So the probability of more than 39 minutes was the 0.6915, or the 69.15%. But if they're asking about like a specific number of people rather than just a percentage, then all we have to do is multiply our probability with the total number of people. So our probability of 0.6915 multiplied by the total number of people, which is 200, we end up with 138.3 people. Okay, this is slightly awkward because like you can't really have 0.3 of a person. Doesn't really make sense, doesn't exist. But remember this word expect right here in the problem or in the question. Expect, expected value, this is just talking about a mean. So kind of like on average, how many people would you expect to be in the store? So averages are allowed to have decimals, so that's why we're going to keep this at 138.3 people, because it's asking about an average. So that's it for this section. If you found this helpful, please like and subscribe. Thanks for watching. Bye. Nani, you're in the way.